Namaskar. Very warm welcome to all the viewers and learners in this live interaction of CIET NCERT. I am Renu Bhatt with you all and you are watching us live on PME Vidya channel, channel number 10. And apart from this channel, you are with us on our YouTube channels as well, that is NCERT Official and NCERT PME Vidya class number 10. And dear viewers, as you can see, I am accompanied by our sign language interpreter. Let's meet him. You are Mr. Ashish Gehlot. Very warm welcome, Ashish. और आप सभी को हम बता दें कि ये सेशन हम लेकर आए हैं साइंस के 10th स्टैंडर्ड स्टूडेंट्स के लिए एंड द टॉपिक दैट वी आर गोइंग टू डिस्कस टुडे इज क्वाइट इंटरेस्टिंग टॉपिक इज लाइट reflection and refraction part second and we have already discussed about it in last previous session. अगर आप उसके बारे में ज़्यादा कुछ जानना चाहते हैं तो you need to explore our YouTube channels और इस सेशन में हम काफ़ी कुछ इंपॉर्टेंट बातें जानने वाले हैं अपने एक्सपर्ट से लाइक रे डायग्राम्स क्या होता है, किस तरह से रे डायग्राम्स को बनाया जा सकता है, क्या क्या उनके एप्लीकेशंस होते हैं और इससे जुड़ी हुई काफ़ी बातें जो बच्चों आपको जानना ज़रूरी है. We have joined by our experts, so without any further delay let's quickly meet her. You are Miss Anuradha Mathur, you are PGT Physics. Very warm welcome मैम. स्वागत है आपका. मैम जो है रिटायर्ड हेड ऑफ डिपार्टमेंट है फिजिक्स की मॉडर्न स्कूल वसंत विहार नई दिल्ली से. एंड डियर व्यूवर्स, इन केस यू हैव एनी क्वेरी और यू वांट टू नो मोर अबाउट लाइट तो आप हमें कांटेक्ट कर सकते हैं हमारे टेलीफोन नंबर पर जो है 8800440559. ईदर यू कैन ड्रॉप अ मेल एज वेल विद ऑल योर फीडबैक्स. हमारा ईमेल एड्रेस है dth.class10@ciet.nic.in. यूट्यूब चैनल्स पे हैं तो आप लाइव चैट बॉक्स में जाकर कमेंट ड्रॉप कर सकते हैं. सो वी आर वेटिंग फॉर योर पार्टिसिपेशन इन दिस लाइव इंटरेक्शन. जब तक आप हमसे जुड़ते हैं हम आज का ये सेशन शुरू करना चाहेंगे और अनुराधा मैम हम आपके पास आएंगे. हमारा टॉपिक बहुत इंपॉर्टेंट है लाइट, रिफ्लेक्शन एंड रिफ्रैक्शन. बट बिफोर वी स्टार्ट दिस पर्टिकुलर सेशन और डिस्कशन क्यों ना हम रिकैप से शुरू करें मैम.
बिल्कुल, वो बहुत ज़्यादा ज़रूरी है कि हमने पहले क्या पढ़ा है या क्या हमने पढ़ा होना चाहिए जिसकी वजह से हम आसानी से समझ सकेंगे. तो एक तो बात है कि लाइट अगर किसी चीज़ पे पड़ती है तो उसका क्या होता है. सो द लाइट इज़ रिफ्लेक्टेड, एब्जॉर्ब्ड एंड ट्रांसमिटेड. रिफ्लेक्शन ऑफ लाइट वी आर कंसिडरिंग इज़ अ स्ट्रेट लाइन पर्सपेक्टिव एंड वी remember the laws of reflection, types of surfaces that reflect more light, and they were plane surfaces, curved surfaces and spherical surfaces. Today we will concentrate only on spherical surfaces so that you get a better idea about them. And then you will remember that we had talked about real images and virtual images, and let us proceed further.
Okay. So मैम आज हम इस टॉपिक में क्या पढ़ने वाले हैं? What is the content of this session मैम?
We are going to learn about ray diagrams.
Okay.
And we are going to see how ray diagrams can actually help us understand the formation of images.
Okay.
And one activity I had asked you to do, and that was with a candle and a big spoon or a cosmetic concave mirror. And all you had to do was to observe the image. The size of the image changed, and then we had also considered spherical mirrors. I have some of them over here, and they were spherical part of a sphere, and that is why they were so special. And if you recall, they had a center of curvature, which was the center of the sphere of which they were part of. And then you talked about the aperture of the mirror, and you talked about the pole, which was the center of the mirror. Every spherical mirror will have these properties. And you will also recall that we could imagine a principal axis which was just a line, imaginary line which was perpendicular to this surface, something like this, going perpendicular to the surface right up, so that you could place everything a little more geometrically. Then we had also seen this in the book, that image formation by concave mirror. For different positions the image changes, and so we are going to now see how the ray diagram is going to help us understand all these things about the images and where they are formed.
Definitely. So ma'am, what is ray diagram? Please explain ma'am.
See, a ray diagram, since we are considering geometrical optics and we are saying that the light we are considering is moving in a straight line. So a line with an arrow is sufficient to say that is the ray. Now, what will be a ray diagram? It is a graphical tool used in physics and optics per se to show the path of light. So, if the light is coming at a particular in a particular direction, so that path and how it will reflect, that will be also part of the ray diagram.
All right.
Then obviously, how do they help? How does a ray diagram help us? It helps us to visualize how rays of light interact with objects, how they reflect, etc. So, now how do we proceed from here, right?
Yes,
so, I will show you that the challenge is that there are infinite number of rays that are falling over here.
Exactly, ma'am. That
right?
is what
and
I was.
So many points there.
Right.
And all the rays will be reflected and they will be following laws of reflection. So, you can imagine the confusion that is created to make that single image that you have. So, but two rays are sufficient to show you the formation of image, and for that you have to choose two rays. So, which two rays are you going to choose? For which the direction after a reflection is known. Now, here we must also understand that what size of image are we considering, what size of an reflecting surface are we considering. So, we are working only with small aperture mirrors. So, you must remember this fact that small aperture mirror, for which small aperture is termed as when the radius of curvature is higher, much higher than the section of the glass that we are considering, like this one. It may have a very large radius of curvature, but a small portion we are considering. So, our option for rays would be, one is a ray which is parallel to the principal axis, and after reflection it will pass through the principal focus. Now, this diagram that you see over here is basically showing you the angle of reflection and angle of incidence as well. So, for both the cases, for both types of mirrors, concave and convex,
I would request my team to have that presentation on screen.
Yeah,
Yes, ma'am.
yeah, that's the one, that's the one. And then let us see this one. Here's another option in which the ray of light is passing through the focus, like here at this point, and at this point it appears to come along this line, and therefore it will be rendered parallel to the principal axis. And of course, you do understand this is the principal axis, this is the pole, the focus and the center, and likewise for the concave surface as well. So, now let us see another option, this is the third one, and what does it say? That if the ray of light is passing through the center, then it will be incident normally on the surface, that means perpendicular to the surface. So, it will retrace its path. Then here is another fourth option, in which if you choose a particular angle of incidence, then the angle of reflection will be exactly equal to that value. So, any of these 4 rays are good enough to draw a ray diagram. You have to choose only 2 of them. So, here's one page in which all the options are given, however with different colors, and you can see that your choice is from any of these. Of course, you will remember that the laws of reflection are true always. Now, how do we start? How do we start a drawing of a ray diagram? Remember, sometimes when we see a ray diagram in a book, we start copying it. That is of no use. We have to first understand why we are drawing and how we will draw it. So, you draw a line, horizontal line, middle of the page, draw an arc, say use a compass, and draw a suitable arc with the center of curvature being on that line that you had drawn. That line is going to represent the principal axis, and you mark the point F as the focus, and this is how you are all set. Now, you will put objects anywhere over here and you will be able to see the image formed in it. So, this is by changing the position of the object in front of the mirror, you get different options for where the image is formed. See over here, you can see some animation, and this will show you how the image is formed. The rays are incident on the concave mirror, and the image is formed from
Ma'am,
it.
could you please verbally elaborate, because due to some technical glitch we are unable to play that video, ma'am.
Okay, okay. So here in this particular, the rays of light from the from this candle will be incident on it, and they will be reflected following the rules.
Okay.
So we choose 2 of the rays out of the 4 that we had selected, and we move on, and then we can see some options here. You will get a real and a virtual image. Here is one option where the rays are coming from a very far off distance, and they are after reflection intersecting at a point F. So the image will be formed at F. Here is another position for the object. I have brought the object closer to the mirror, and in this case the image is formed at this point. A dash B dash shows the image of A B. So this arrow is inverted, and this is how you will get here one ray, another ray, and for B we have the ray moving in this direction because it is perpendicular to the surface. Here is another option where you can see how the size of the image is changing, and so also the position of the image is changing. Now in this case, when you brought the object to say the focus, then the rays would be rendered parallel, and so they should never meet. But what happens is, because of perception of vision, you kind of see the image even then. And this last case is a unique one in which the object is placed between the pole and the focus, and in this case you are not going to get any reflected ray meeting at a point.
Okay.
In fact, it would appear as if it is coming from a virtual spot A dash somewhere over here. So A dash would be a virtual image of A. So A dash B dash is the image of AB. It is enlarged, it is virtual, and it is erect. So images in convex mirrors likewise, you can use again 2 rays to do it, but here it is much simpler because wherever you put the object in front of the convex mirror, choosing any 2 of these rays will give you an image which is diminished, erect, between the pole and the focus, and it is going to be virtual image in this case. So I have an example over here. I hope you can see the screen, and there are 3 images formed in these 3 convex mirrors. There is 1, 2 and 3, and the object is obviously at the same location. But why is it happening that there are 3 different images and they are of different size? And this is because the radius of curvature is different for all these 3 surfaces. You cannot understand it straight away unless you draw a ray diagram. So a ray diagram is in fact a very helpful thing, and we are going to see some applications of the ray diagram. So first one is that how do you get this wide field of view? Everybody says, oh, you use a convex mirror because it gives you a very wide field of view. How is that happening? Because all the rays are being reflected away from the mirror, and this ray was incident and it went down like this. This one went right out like that. So for your eye, you are seeing what was originating from this point as well as this point. So a very wide range of this thing, and here is the ray diagram which shows how this is visible to you as a wide field of view. This is your traffic mirror. If you have not seen it, you must go and see it because it is a very good looking thing, and it is placed at locations where the road is at 90 degrees. So you actually cannot see the traffic coming from this side. So what you have to do is to be able to see this. I think this video is not playing, so you will have to go and make a video for yourself and enjoy this very beautiful thing. And do you know the aperture of this mirror is about 90 centimeters. This is only a half meter rule. So 90 centimeters is about this much or even a meter, and their focal length is about 3 meters. So it is a huge thing like that. And when you observe all the cars coming from all the sides, it is a very nice feeling. You do go and look at it, then you will understand. Now inversion of image in concave mirror, I will show you. This is my, say this is my object, right, and this object when you see through the concave mirror is going to appear not like this but like this. Okay. So I don't know if you are able to see it. Let me make it a white background. So this was my object,
Okay.
and the image came out to be like this. That means there was inversion, which made it go ulta,
Huh.
and there was also inversion like this. So this you can only understand if you can draw ray diagrams, otherwise you can't. Supposing here is my object, right? Now for this object there are different options given. How could I have held it so that I get an image, some images? How will I get an image like this if I held it like that? That means as I am showing. And how will I get an image like this if I held it in this way? That means the arrow being on this side, and so the image will be obviously formed like that. So, and if I want a vertical arrow, then this should be my image object, and my image will be looking like this. That is the one which is here, this one. And if I want some other direction, if this is the orientation, then the image will come out to be in this direction. Okay. Now, it is important to see this because the ray diagram is the only thing that can explain how this is happening, including what happened to the bird. So, now if you were to take a convex mirror, then what happens to this birdie? This birdie will only become a little smaller. It will have an inversion like the plane mirror has. So, this beak will be formed right there,
Okay.
and the bird will just look smaller.
Okay.
Okay? So, it is not like the plane mirror image, but there is a similarity of inversion. So, you have noticed some ambulances, ulta ambulance written in front, everywhere else at the back, everywhere it says. Why is that? Because the person who is driving before him has a rear view mirror,
Right.
and which is a convex mirror. And what he sees in the rear view mirror is the ambulance which is written like this. So, the car driver has to make way for the ambulance because the ambulance needs to go fast, and that is why this is a very, very important and relevant. Now, two problems we will solve quickly, and that is how the ray diagram helps.
Ma'am, here let me tell you that we have 3 more minutes left for this session, ma'am.
Okay, 3 minutes I will finish, I will be done in that. Okay, if you have to draw a ray diagram, AB is here and A dash B dash is the image, because 1 and 2 are the two rays which we have considered. Look at this one. A convex mirror is used for rear view on an automobile, has a focal length of 3 meters, has a and a bus is located which is 2 meters in height and is located 6 meters from the mirror. Draw a ray diagram to find the position of the image of the bus. So, here is what you have done. You have just drawn a ray diagram and you find that the image is virtual, it is formed here. It is erect, it is about 70 centimeters if you were to read off from the graph sheet, and located about 2 meters behind the mirror. So, this is what it will look like. Okay? So, it will have lateral inversion, but the small image will be seen. So, that is all I have for you right now, and yes, open to any questions if you have.
So, ma'am, is there any key points that our students need to remember, ma'am?
Yes, very important. One thing which I missed out, I think, by saying that when you see a ray diagram in a book, don't start copying it. First look at the object. Where have you placed the object? Which are the two rays you are going to consider to draw the ray diagram? And then you draw it yourself. Like I told you, from the starting point, draw the line, make the concave surface, put the center of curvature, put the pole, and then you proceed. You will never go wrong. In fact, you will have fun and enjoy making the ray diagram because it immediately shows you how the image is formed.
Right.
Okay?
तो डेफिनेटली आप सभी को बहुत मज़ा आने वाला है इसे जब आप करेंगे. एंड इट्स टाइम फॉर मी टू रैप अप दिस सेशन बिकॉज वी आर रनिंग वेरी शॉर्ट ऑफ टाइम. सो थैंक यू सो वेरी मच अनुराधा मैम. थैंक यू फॉर बीइंग हियर. थैंक यू मैम फॉर दिस इंटरेस्टिंग टॉपिक एंड एक्सप्लेनेशन. और आशीष, हम आपको भी धन्यवाद करते हैं. यहाँ पर अपने सभी देखने वालों को हम ये कहना चाहेंगे, इन केस यू वांट टू ऑर्डर 4th and 7th grades NCERT न्यू टेक्स्ट बुक्स, यू कैन ऑर्डर इट फ्रॉम Amazon, Flipkart and from NCERT official website. और हम आपको आगे आने वाले सेशंस की डिटेल्स बता दें। आपसे कुछ ही देर में अपने एक और लाइव इंटरेक्शन के साथ हम हाजिर होंगे, जो कि हमारा ऑनलाइन ट्रेनिंग प्रोग्राम है, जिसमें हम बात करने वाले हैं डिजिटल टेक्नोलॉजी फॉर रीचिंग द अनरीच्ड। और सहयोग सत्र में हम बात करेंगे एड्रेसिंग बॉडी इशू, इमेज इशू एंड सेल्फ परसेप्शन अमंग स्टूडेंट्स ड्यूरिंग एडोलेसेंस। 5:30 बजे नीपा में हम बात करने वाले हैं अपने मध्य प्रदेश के एक स्कूल हेड से, जो अपनी पूरी जर्नी आपके साथ साझा करने वाले हैं। और आप अपनी सभी क्वेरीज के साथ हमसे इस लाइव इंटरेक्शन में जुड़ सकते हैं। अब मैं रेणु भट्ट आप सभी से ले लेती हूँ अनुमति। आप बने रहे PM ई विद्या चैनल्स पर और अधिक रोचक और ज्ञानवर्धक कार्यक्रमों के लिए। नमस्कार।